All right, folks, so this is 3.5, rational functions and asymptotes. So asymptotes, again, are basically lines that a graph can get super close to but can't actually touch. So in these, it's these pink dotted lines. So you can see the graph gets really close but then swoops up out of the way. Here it gets really close, swoops down out of the way. And there's both horizontal and vertical asymptotes. So that pink one is vertical, and this orange one would be horizontal. Now notice, I'm going to zoom in super close. This is y equals 2 because it's at a height of 2 on the y-axis. This one, the equation would be x equals -1. Put it up here because it happens at -1 on the x-axis. So what we're going to look at is how you determine if and where those exist. So first, we have we're going to look at vertical asymptotes. So I'll often shorthand that as VA. And this is when, as you see here, you put the bottom equal to 0. So any number that makes the denominator 0 would cause a vertical asymptote. So just to maybe do those all at once, we could look at, like here, this first one. If we set the denominator equal to 0, and then we solve it, we would have a vertical asymptote at x equals -1. And then for this one, if we took the denominator, set it equal to 0, and solved it, we'd have to square root both sides here. And then just be careful, remember that you get 1 and -1. So there would be 2 vertical asymptotes here. And then the last one, if you guys want to try this one, go ahead and pause it. What you would do is set the bottom equal to 0, and you would solve it. So all of those would have vertical asymptotes at those locations. The second thing is horizontal asymptotes. Often I'll use HA for that. This one is not necessarily super complicated, but it just it takes a little bit more thought. And what you're doing is, like it's highlighted here, you're going to compare the highest degrees in the numerator and denominator. So for this first one, horizontal asymptotes, when we look at the degree, that means like the highest powered exponent in the numerator. We have 5x. That's the term that has the highest power. In the denominator, the term that has the highest power is just x, because this has a power of 0 and this has a power of 1, so that one's bigger. So when we look at our 3 different scenarios for what could happen, scenario A is that if the degree of the denominator is bigger, so the bottom is bigger, then we would have y equals 0 as an asymptote. So bottom is big, y equals 0. Then I'm going to skip to C. So C, this scenario is if the degree of the numerator is bigger, then there's no horizontal asymptote. So this means if the top is big, there's none. Now, the third scenario, or the second one listed, is B. This is where they have the same degree, and you have to reduce the highest power. What you're going to reduce specifically are the coefficients. So in this scenario, for number 1 that we're looking at down here, those have the same power. They're both a power of 1. So this would be, let's see, scenario B, or I'll call it rule B, which is this guy right here. What we have to do is reduce the coefficients. So here we have a coefficient of 1, so it's going to be 5 over 1, which really is just 5. That means that we have a horizontal asymptote at y equals 5, okay? So then we look at the second one, our horizontal asymptote. We look for the highest power in the top and bottom, numerator and denominator. 4x is the highest power in the top, and then x squared is the highest power in the denominator, or the bottom. So if we look at our three options, either the bottom is bigger, they're the same, or the top is bigger, sorry. And in this case, the bottom is bigger. So we're looking at scenario 1, or we'll call it rule A because that's less to right. So what we would say there is, since it's rule A, we have y equals 0 as our horizontal asymptote. And then for the last one, we do the horizontal asymptote. We look at, again, highest power in the top would be x squared, and in the denominator would be just straight up x, because that one, again, is a power of 0. So we look at our two options. I should have put this here. I'm sorry. They'll be equal in the second scenario. The top will be bigger in the third, and the bottom will be bigger in the first. So in this case, the top is big. So what we would say in this case is that there is none, because this is the scenario we're looking at. We're looking at rule C. All right. So then, if we check out the next page, we're going to do a couple more examples, but we're also going to introduce something they're called holes. So I believe you spoke about these in Algebra 2, but I'll just remind you just in case. So a hole is where anything cancels out. So, let's see, if we had like, these would end up canceling out, so we would end up with a hole there, and I'll show you how you would deal with it. One thing, just to make sure you guys remember, is if you have something like this, you can't cancel those x's. One of my teachers always said, if it's a butt, don't touch it. So it kind of looks like a butt because there's 2 in the bottom. I don't know. But you can't cancel x's like this. It has to be whole chunks like in that first one. Okay, so the first thing we'd have to do is just factor all of this stuff and break it into smaller pieces. So on top here, we could pull out a 2, and then we'd be left with x minus 4. Because if you distribute the 2, you're back where you started. Then on the bottom, what we're going to do is, I know some of you guys like this, we're going to figure out what multiplies to 20 and adds to -9. If you want to pause and think about it, you can. It would be -4 and -5. So x minus 4 and x minus 5. Now, what you'll notice is the x minus 4's cancel out. So there's going to end up being a hole there, okay? But let's go ahead and we'll deal with our vertical asymptotes and horizontal asymptotes and stuff like that, okay? So for the vertical asymptote, remember, we set the bottom equal to 0. So when we factor these, this cancels out, and what you're left with is 2 over x minus 5. So for this one, you're going to want to use the reduced version, okay? So what we would do is we would say, okay, x minus 5, set it equal to 0. We have a vertical asymptote at x equals 5. Then we would look at our horizontal asymptote. And in this case, what you're going to want to do is use the, it really shouldn't matter, because if you drop, this might not make sense when I'm explaining it via video, but if you drop a term on the top and the bottom in the numerator and denominator, the highest x power is going to reduce by 1 either way. But it's maybe a little easier to look at the original in this case. because then we clearly have 2x on top and x squared on bottom. So if we look back at our three options, here the bottom is bigger, the denominator is bigger. So we're looking at rule number 1, where if the bottom is bigger, y equals 0 would be your asymptote. And then the last thing we need to do is figure out how to deal with these holes. So holes are anything that cancels. So in this case, it would be x minus 4. So if we set that equal to 0, nope. Yeah, okay, sorry. If we set that equal to 0, we get 4. And then what you're going to do is you're going to put that into the reduced version. So we're going to take 2 over 4 minus 5, like that. And it's going to become 2 over negative 1, which is negative 2. That's going to be your y value, like your output. So what happens is there's a hole at 4, negative 2. Okay. So this came from that, and then when you put it in, that's what you get out. Okay? So let's look at the next one. If you guys want to pause and try this one, go for it, okay? All right. So vertical asymptote we'll do first. We need to use the reduced version. So let's go ahead and factor it and see if anything drops off. So up top here, you see how we have minus and then a number you can square root. So this is the one I was mentioning where you can square root 4 and then you just do minus and plus that number. And then on the bottom, all we have is x minus 2. So in this case, what's going to cancel off is x minus 2. We're going to have a hole there. So all that's left is x plus 2. That's all we have. So in this case, there's not going to be a vertical asymptote because there's no denominator. We don't have anything underneath for us to worry about. So we would just say none. Next, we're going to look for our horizontal asymptotes. Again, you could use either one, but just the original might be easier in this case. So if we look at the original equation had a highest power of 2 in the top, or numerator, and a highest power of 1 in the bottom, or denominator. So this, when the top is bigger, if we look up here, top is bigger, there's none. It's a pretty simple situation here. No asymptotes. All right. So then the last thing, this is the new part for these ones, is to look for holes. So let's look at the reduced version. And what we're going to do is say, all right, the thing that canceled off was x minus 2. If we set that equal to 0, we get x is 2. So that's the first part of our hole. Then we're going to put that into the reduced equation. So something plus 2. And in this case, the x, this is where it's coming from. We're doing 2 plus 2. So we get 4. So this is from what comes out here, and then once you plug it in. Okay. Oh, I thought we had another example. I guess that's it. Well. One thing I just want to make sure you guys know is, like, up here, I know I'm not trying to, like, just make you spend time listening, but when you have a vertical asymptote, I just want to make sure you understand that when it's x equals negative 1, you're going to go here, and it's going to be dotted like this. And then when you have a horizontal asymptote at 5, it's going to go up 5, and you're going to have it like this, okay? In the second one, this is a goofy one. I just want to make sure you know how to visualize it. You'd have a vertical here and here at 1 and -1. And then you would have a horizontal at 0. So you'd have some crazy stuff going on in there. You could graph it and see what it looks like, but that's the long and the short of it. If you guys have any questions or anything that was not clear, just make a note and I will answer whatever questions you have.